In a certain game of chance, a square board with area 1 is colored with sectors of either red or blue. A player who cannot see the board must specify a point on the board by giving an X coordinate and a Y coordinate. The player wins the game if the specified point is in a blue sector. The game can be arranged with any number of red sectors, and the red sectors are designed so that Ri equals 9 by 20 power I, where Ri is the area of the ith red sector. Calculate the minimum number of red sectors that makes a chance of a player winning less than 20%. So the player wins if the player misses the red sector, because to win you have to land in a blue sector, and landing in a blue sector is equivalent to missing a red sector. The reason why we are talking about the red sector is that those are the ones for whom we have the area expression. So let's say that there are n red sectors. So then the total area of the n red sectors will be the summation of all these from I equals 1 to n, because this is the area of the ith red sector. So that's the total area of the n red sectors, the ith area, and you're summing from I equals 1 to n. Now this is a geometric sum with first term 9 by 20, which you can see when you put I equals 1. So this gives you 9 by 20, and the common ratio is always this base. And we know that a geometric sum with n terms equals a times 1 minus r power n over 1 minus r, where a is the first term and r is the common ratio. So now note that this is not a geometric series. A series is one where the terms are infinitely many. Here we have only a finitely many terms, so we call this a geometric sum instead of a geometric series. And in this case, both a and r will be 9 by 20, because first term is 9 by 20 and ratio is 9 by 20. So putting these values for a and r, we get 9 by 20, 9 by 20 here, 1 minus 9 by 20 power n over 1 minus 9 by 20. Now this one, 1 minus 9 by 20 is 11 by 20. When you multiply that by 20, you just get 11. And we have a 9 at the top, so it's a 9 over 11 times this thing. And then you distribute the 9 over 11. Now this is the total area of the red sectors. The winning probability is if you land into the blue, so that will be the complement of this total area of the red sector. So 1 minus this, so that will be 2 over 11 plus 9 over 11 times 9 by 20 power n. And we want this winning probability to be less than 20%. Remember, the question was find the minimum number of red sectors so that the winning probability is less than 20%. So you set this is the winning probability, you set this less than 20% or 0.2. And now this 2 over 11 gets subtracted on this side, and 0.2 minus 2 over 11 equals 0.2 over 11. And then the 11 can be multiplied out on both sides, and the 9 gets divided here, so you get this. And then you take ln of both sides. So now the important thing to note here is that ln 9 over 20 is a negative number. You can calculate it and see that it's a negative number. And therefore, when you divide both sides by ln 9 over 20, the inequality will get reversed, because you know that the inequality gets reversed when you divide both sides by a negative number or multiply both sides by a negative number. So when you divide by ln 9 by 20, we end up getting n greater than 4.767. So the question was to find the minimum integer, which makes the winning probability less than 20%. So the minimum integer needs to satisfy this requirement, because that's what we got after setting the winning probability less than 20%. So this is telling us that the minimum integer needs to be 5, because 5 is the minimum integer which is greater than 4.767. So now note here that we are not saying that it's 5 because this 4.767 is greater than 4.5. Even if this had been like a 4.1 and you were seeing n greater than 4.1, still you will have 5 as the answer, because the minimum integer greater than 4.1 is 5. So this is not a case of mathematical rounding, but it's a case of understanding what the problem is saying, and you have to round it up to the next integer no matter what. So the 5 was choice C.